10, 11, and 12, we're back to doing proving trigonometric identities. This time we're going to add the sum and difference properties. So you're going to want a couple different sets of notes. First of all, you want the one that has a whole bunch of your identities. We've got our reciprocal identities, such as the sine of u is 1 over the cosecant. Our quotient ones, where we take tangent and cotangent and put them in terms of sine and cosine. The Pythagorean identities. We haven't talked much about the odd and even ones, but we occasionally use those. So mainly those first three. Then we also want the sum and difference identities, because we're going to turn these ones into these ones. And so we'll end up with something like sine of A cosine of B plus cosine of A sine of B, and turn it into sine of A plus B. So you'll want that sheet with your sum and difference identities, and your other sheet with the rest of your identities to use for reference. And if I can get back to our question. So we are going to prove our identity. We're going to put it in terms of the cosine of x plus y and the sine of x minus y. And if you look at those identities, they're all in terms of sine and cosine. So I want to change my tangent and cotangents into terms of sine and cosine. And so I'm going to use those quotient identities to do that. You can do it all at once since you're using the same one. And so for cotangent, I'm going to have cosine over sine. So I'm going to have the cosine of x over the sine of x times the cosine of y over the sine of y minus 1 all over cotangent again. So cosine of y sine of y minus cosine of x over the sine of x, using my quotient identity to replace all of my cotangents with cosine over sine. The next step there, I want to basically make this into one fraction, this into one fraction by using my common denominator, sine of x, sine of y. Same thing here, sine of x, sine of y. So I'm just going to do some algebra. So in this case, I'm going to have cosine of x, cosine of y, minus, and I'm going to have to take this times the sine of x, sine of y. Sine of x, sine of y. That's going to put that all over sine of x, sine of y. On the bottom, we have a really big fraction. I'm going to end up taking this one times the sine of x, this one times the sine of y. So I'm going to have the sine of x cosine of y minus cosine of x, x, sine of y over my common denominator, sine of x, sine of y. Doing algebra. Again, I'm writing too big, so it never ever fits on my thing. But my next step, I have one fraction divided by another fraction. I can invert and multiply. So this is going to be sine of x, sine of y over sine of x cosine of y minus cosine of x sine of y. And then I'm going to be able to cancel that out. And so I'm going to end up with this on top, this on the bottom. So cosine of x, cosine of y, minus sine of x, sine of y, over sine of x, cosine of y, minus cosine of x, sine of y. And that again, writing that right on top of my other junk, just doing algebra again. So now what you should notice here is that I have cosine of x, cosine of y, minus sine of x, sine of y, which is your cosine of x plus y. And on the bottom we have sine of x, cosine of y, minus cosine of x, sine of y, which is your sine of x minus y. And that is using the sum and difference identities. So I should have 4 steps to that problem. First of all, replacing your cotangent using your quotient identities, doing algebra to find your common denominator, doing algebra again when you multiply by the reciprocal to get rid of those, and then replacing with the sum and difference identities, and now you have it solved. So number 11, we want to prove the identity. This time we have the cosine of x minus pi over 4 minus the cosine of x plus pi over 4. So we're going to use the cosine of a minus b, the cosine of a plus b, and then simplify to see if we can figure out what we're doing. So if we go ahead and do that, if I have the cosine of x minus b, I'm going to take the cosine of x, cosine of pi over 4, plus sine of x, sine of pi over 4. There's my difference. Then I'm going to have minus, if I have a plus b, I'm going to have the cosine of x, cosine of pi over 4, and that's going to be minus cosine of x, cosine, that should be sine, sine of x, and sine of pi over 4. That's using our sum and difference identities, as we always have to pick out which property we're using. So just expanding that using our sum and difference. So now we're going to substitute in here, or simplify here. Let's see here. We are going to do cosine of x, cosine of pi over 4, minus cosine of x, cosine of pi over 4. So those are going to cancel out. When I subtract a negative, I end up adding, so I'm going to have 2 of those. So I have 2 sine of x, sine of pi over 4. Just doing my algebra, subtracting my 2 expressions. Then I'm going to look up at my table. In my table, I have the sine of pi over 4. If I look at the sine of pi over 4, it's square root of 2 over 2. So I have 2 sine of x, square root of 2 over 2. And they're going to call that step evaluation. We haven't used that yet. Yep, I can even spell it. Evaluation. So if I have to look up the table and find what the sine or cosine of an angle is, they're going to call that evaluation. Now in this case, I can cancel this out. Move that to the front. I have square root of 2 sine of x. And again, that's just using algebra. And I have my identity proven. Number 12, we want to prove our identity. Again, we start with the sine of x plus y. So we're going to go ahead and substitute in for the sine of x plus y. So I'm going to have the sine of x, cosine of y, plus cosine of x, sine of y, over my cosine of x, sine of y. That's using my sum and difference identities, just substituting in for the sine of x plus y. Next thing I'm going to do is just separate that into 2 separate fractions. So I'm going to have the sine of x, cosine of y, over the cosine of x, sine of y, plus cosine of x, sine of y, over cosine of x, sine of y. So that's just doing algebra, just breaking it down into 2 separate parts. And again, I'm just going to do some more algebra here, because if you notice, I've got the exact same thing over itself, so I can change that into 1. So I'm going to have the sine of x, cosine of y, over cosine of x, sine of y, plus 1. Algebra. Now notice that I have sine of x over cosine of x, which is the tangent, cosine of y over the sine of y, which is the cotangent. Those are my quotient identities. So sine over cosine would make that tangent of x. Cosine over sine makes that cotangent of y. And that's using my quotient identities. And you can see that I've proven my identity. I ended up with tangent of x, cotangent of y plus 1.